7.5, we're going to be performing operations with matrices. So we're going to be adding, subtracting, multiplying matrices together, multiplying by a scalar, all the fun stuff. So when adding and subtracting, dimensions of your matrix, your matrices have to be the same. So we can only add like a 2 by 3 plus another 2 by 3. So your dimensions have to be the same size when you're adding them. If the dimensions aren't the same, then they cannot be combined. So when we're adding our matrices together, let's look at example 2a. We're going to add the first number with the first number. So the numbers in the same exact spots get added together. So that's why they have to be the same size. So when we're adding here, what is -1 plus 1? 0. Awesome. Then the second number with the second number. What's 2 plus 3? 5. And then we have 0 plus -1. What's 0 minus 1? -1. And then 1 plus 2? 3. So this would be our answer. For B, are our dimensions the same size? Yes, so we can add them together. So we're going to add the numbers in the same spot. So 1 plus -1 would be 0. -3 plus 3 would be 0. And -2 plus 2, 0. What about C? What's the dimensions of A here? A 2 by 3, we've got 2 rows and 3 columns. What's the dimensions of B? A 2 by 2. Can I add a 2 by 3 with a 2 by 2? No, so we cannot combine them together. So can't add. In example 3, we're multiplying by a scalar, so we have 3 times matrix A. When we multiply 3 times the entire matrix, it gets distributed to everything in our matrix. So 3A would be 2 times 3 is 6. 2 times 3 would be 6 again. And 3 times 4? 12. And then 3 times -3? -9. 3 times 0? 0. 3 times -1? -3. 3 times 2? 3 times 1? And 3 times 2? Awesome. So this would be our new matrix. So we just have to make sure we distribute that scalar to everything in our matrix. In example 4, it wants us to find 3A minus B. So just like how we perform our order of operations when we do regular math, we got to do the same thing here. So we have to find what 3A is first. We got to multiply before we can subtract. So 3A, is this the same A that we had in the last one? Yeah, so we just want to copy and paste it, but we'll distribute all again. So we've got 6, 6, 12, -9, 0, -3, and 6, 3, 2. Oh, 6, sorry. Now we're subtracting 3A, which we just found here, minus B. If you want to rewrite B again here, I'll do that just so we have them in line. But just be careful. It's just a lot of little math going on. It's a lot of adding and subtracting. You guys know how to do this. But be careful. We're subtracting 9 different times here. So just be careful with the math. So our dimensions are the same size, so we can subtract. So our answer is going to be the same size. So we just have to subtract the numbers in the same spot. So we've got 6 minus 2. What's 6 minus 2? 4. Then we have 6 minus 0, which is 6. And 12 minus 0? 12. Perfect. Let's move on to the second row. We've got 9 minus 1. What's 9 minus 1? 9 minus 1? Oh, -9 minus 1. Sorry, I missed the negative there. Negative 9 minus 1 would be negative 10, yes. 0 minus negative 4. Positive 4, perfect. And negative 3 minus 3, negative 6, awesome. Then in our third row, we've got 6 minus negative 1. What's 6 minus negative 1? 7. And then 3 minus 3, 0. And 6 minus 2, 4. Awesome. So this would be our answer. Let's look at example 6. So example 6 looks similar to what we just did in example 5, but it's a little bit different. It says solve for x in the equation. The first thing we want to do is get our equation to be x equals. I want to solve for x in the equation here. Then we can plug in our matrices. So how would I solve for x? What should I do first? Subtract a on both sides. Perfect. So we've got 3x equals b minus a. Then what do? Divide by 3. So we have x equals b minus a over 3. So a couple different ways we could do this if you wanted to. You could find what b over 3 is and then subtract a over 3. But when you do this, you're multiplying by that scalar of 3 to everything. What I would recommend is just doing b minus a and then divide by our scalar of 3, or we're going to multiply by 1/3. So we're going to find b minus a first. Now when we find b minus a, I would recommend rewriting it in this order. When you're adding, it doesn't matter what order you add them in. When you're subtracting, it does. So instead of trying to think backwards for each one that you do, I would rewrite it in the order of b first and then a. So b is negative 3, 4, 2, 1 minus a, which is 1, negative 2, 0, 3. So we have negative 3 minus 1. What's negative 3 minus 1? Negative 4. What's 4 minus negative 2? 6. 2 minus 0, 2. And 1 minus 3, negative 2. Awesome. Now the last step is we have to divide by 3, or we could multiply by 1/3. So when we multiply by a scalar, it gets distributed to everything. So here we have negative 4 over 3. 6 over 3 would simplify to what? 2. Then 2 over 3 and negative 2 over 3. So this would be our answer. So you always want to solve for x first. Then take whatever x equals and you're going to plug in your matrices from there. So we had to do b minus a and then divide by 3 or multiply by 1/3. Next, we're going to be multiplying matrices together. When we multiply matrices, your dimensions don't have to be the same, but they do have to follow a certain rule. So if I had, let's say, a 3 by 2, and I'm multiplying that to a 2 by 4, the inside numbers, so the inside dimensions, the columns of the first one and the rows of the second, have to be the same in order to multiply them together. So the order that you multiply them matters. Whatever your two outside dimensions are, is the size of the answer. So if I had a 3 by 1, and I'm multiplying that by a 1 by 2, can I multiply these together? Yeah, because the inside numbers are the same, so that tells me that I can multiply it. What's going to be the size of my answer? A 3 by 2. What if I had a 2 by 3 and I'm multiplying that times a 2 by 3? Can I multiply these together? No, the insides are not the same. So we can't multiply these together. So the order that you multiply them matters. If we have two matrices A and B, just because we can multiply A times B does not mean that we can multiply B times A. So the order matters. So when we multiply our matrices, let's check the sizes first. What's the size of A here? A 3 by 2. We've got 3 rows and 2 columns. What's the size of B? A 2 by 2. Can I multiply these together? Yes, the insides are the same, so we can multiply. What's the size of our answer going to be? A 3 by 2. So we're going to have 3 rows and 2 columns. So I think it's helpful. Draw the size of your answer, especially if you're using Notability or something. I would highlight the spots here. So we've got 3 rows and 2 columns. So it's going to be this size. Now, when we multiply matrices, just like how when we talk about the dimensions, we move row by column. So in the first matrix, I'm going to start with the first row. In my second matrix, I'm going to start with the first column. So first matrix, we move in rows. Second matrix, we're going to move in columns. Now we take the first number times the first number. So we have -1 times -3. And we're going to add that to the second number times the second number. So 3 times -4. So the first number times the first number plus the second number times the second. What's -1 times -3? 3 plus, what's 3 times -4? -12. And 3 plus -12? -9. Awesome. So that's going to go in my first row, first column spot. Now we can stick with the first row. We'll go first row, second column. So we're going to multiply the first number times the first number. So -1 times 2 plus the second number times the second number. 3 times 1. -1 times 2 would be -2 plus 3 times 1 is 3. And what's -2 plus 3? 1. Awesome. So my first row, second column spot would be 1. Let's move on to the second row, first column. So in the second row, first column, we multiply the first number times the first number. So 4 times -3 plus the second number times the second number. -2 times -4. What's 4 times -3? -12. What is -2 times -4? 8. And -12 plus 8? -4. So that's going to go in the second row, first column spot, -4. Let's move on to the second row, second column now. So second row, second column. So we've got the first number times the first number. So 4 times 2 plus the second number times the second number. -2 times 1. 4 times 2 is 8. Negative 2 times 1. So 8 plus negative 2, or 8 minus 2 would be 6. Awesome. Let's move on to the third row now. So the third row, first column, the first number times the first number would be 5 times negative 3, plus the second number times the second number, 0 times negative 4. 5 times negative 3 is negative 15. 0 times negative 4, and negative 15 plus 0, negative 15. Awesome. Last one, we've got the third row, second column now. So that's going to go in the third row, second column spot. So we multiply the first number times the first number, 5 times 2, plus the second number times the second number, 0 times 1. 5 times 2 would be 10. What's 0 times 1? 0, and 10 plus 0? 10. Awesome. So this would be our matrix. So in the first matrix, notice my highlights here. They're only going in rows. We are only moving in rows in our first matrix. In my second matrix, notice my highlights. We only move in columns. So it's always row by column. Let's look at example 8. Here we're multiplying our matrices together. What are the dimensions of our first matrix? A 2 by 3. Awesome. What's the dimensions of our second matrix? A 3 by 3. Can I multiply these together? Yes, the insides are the same. What's the size of my answer going to be? A 2 by 3. So we're going to have 2 rows and 3 columns. So I'm going to draw the size of it for us. We've got 2 rows and 3 columns. So I'm going to have 6 spaces in my answer. And then remember, in the first column, we move in rows. Second column, first matrix, we move in rows. The second matrix, we move in columns. So think row by column. So starting with the first row, first column. So here we've got 3 numbers. We're going to multiply the first times the first. So we have 1 times negative 2, plus the second times the second, so 0 times 1, plus the third times the third, so 3 times negative 1. So 1 times negative 2 would be negative 2, plus 0, plus negative 3. What's negative 2 plus 0 plus negative 3? Negative 5. Awesome. Let's move on to the second spot now. So we're going to stick with the first row. Second column. So we have 1 times 4, first number times the first number. Second number times the second number would be 0 times 0. Plus the third number times the third number, 3 times 1. So 4 plus 0 plus 3. What's 4 plus 0 plus 3? 7. Awesome. Now let's do the first row, third column. So that's going to go in the first row, third column spot in our matrix. So first row, third column, first number times the first number would be 1 times 2, plus second number times the second number, 0 times 0, plus the third number times the third number, 3 times negative 1. 1 times 2 is 2, plus 0, plus negative 3. So it's 2 minus 3. Negative 1. Awesome. So that's going to go in the first row, third column spot, negative 1. Now let's move on to the second row. So second row, first column. Second row, first column. We've got 2 times negative 2. What do I multiply next? Awesome. Negative 1 times 1. And what's next? Negative 2 times negative 1. Perfect. So negative 2 times 2 would be negative 4 plus negative 1 plus positive 2. What's negative 4 minus 1? Negative 5. And negative 5 plus 2? Negative 3. Now let's move on to the second row, second column. Second row, second column. So we've got 2 times 4 plus the second number times the second number would be negative 1 times 0 plus the third number times the third number, negative 2 times 1. 2 times 4 is 8, plus 0 times negative 1 is 0. Negative 2 times 1 would be negative 2. So 8 minus 2 is 6. Perfect. One more. So now we have the second row, third column. Yes. Second row, third column, we have 2 times 2. What would I multiply next? Negative 1 times 0 plus negative 2 times negative 1. So this gives us 4. Negative 1 times 0 would be 0. And negative 2 times negative 1 is 2. 4 plus 2? 6. Awesome. So this would be our answer. So what we're doing is a lot of little math. Just be super careful with each step. Adding and subtracting is super straightforward, but multiplication might take a little bit more practice. So just make sure you practice these questions. WebAssign is going to be due Monday.